Hey guys, welcome back. In previous video we did pre-order traversal iteratively. In this video I'll be doing in-order traversal both iteratively and recursively, which is the section of the chapter. So let's first get an idea what is in-order traversal. In in-order traversal we visit the left subtree first, and then we visit the root, and then we finally visit the right subtree. So let's look at this example. We are at f, but f is a tree, so we'll go to its left subtree, which is b. B is again a tree, so we'll again go to its left subtree, which is a. But a is a leaf node, we'll append it to our output array. Then we'll go back to its root b and visit it, and then we'll go to its right subtree, which is d. And it has a left node, so we'll go to the left node and visit the leaf node, and then we come back to D, and then we visit E, and so on. So I hope you got the idea what is happening in order traversal. So let's go ahead to the code. As in pre-order traversal, we'll do this in the same manner. That is, we'll have a stack to keep track of nodes and an output array which we will return. So if not root, if we have if the root node is null, the input is null, then we will return the output as it is. Now in this one we will go in an infinite loop. We will visit each node, check if it is a tree. If it is a tree, we go deeper to its left node, visit it, and so on. So let's try to understand with code. So we are at root, so we'll check for it. While root is not null, we will append this to the stack. And we'll go ahead to its leftmost left subtree. So if the root is supposed 3, then we'll simply have in stack 3, and the root dot left would be null, so it won't go again in this one, and so we'll have the leftmost leaf in the tree we are into. Now if not stack, if the stack is null, we don't have any nodes to visit. Now we return the output. We are done here, so we return the output. Now we have all of our left node in our stack, so now we'll visit it. So for visiting, we simply pop off the element from the stack and append its value to the output array. And then we go ahead to the right subtree. So if we kind of go iteratively in the given example, we are at 1, we append it to the stack, but same, it doesn't have any in this loop. It doesn't have any left subtree, so we'll simply append 1, and it won't go again in this loop. The stack is not empty, so we'll pop off 1 again, and we'll append output the value of 1 into the output array, and then we'll go to the right node, which is 2. So we'll append this to the root is now the right node 2. Now we came back again, the root is not null, so we append 2 to the stack, and then we go to the left one which we have, which is 3. We come again, we append 3 to the stack. Now now it won't again go into this loop, and we'll check this condition. We won't return anything yet. Then we pop off the recent element, which is 3, and append it to the output, and then again we come again. We don't have any write or stuff here, so we again so we go on, and we finally get this, because after a while we get the stack empty and we return the output. So this was the iterative solution. Let's run it. Hope it works. Yeah, we're getting the expected output. Let's submit it. So now we'll go ahead for a recursive solution. For recursive solution, we will make a helper function. So recursively, we will go deeper into the left part of the tree. Okay, so let me think. We'll have the same thing here. We'll have an output array which we're gonna return. We'll call a function, let's call it helper, with root and output array. We'll modify it in this function, and then we'll return the output. Root. Okay, so if the root is not null, like if the root is true, we want to go to the left part. We want to go to the left subtree. So if root dot left exists, it is not null, then we'll call this function recursively. We'll call this function recursively on the left subtree. Okay, so now once we are done with the left subtree, we'll visit the current subtree, the root of the current subtree we are on. Like, we will visit the root as in our traversal. So output dot append the value of the current we are on. I'm not so good at explaining, but I try my best. Then we'll visit the right if it exists. Sorry. If it exists, we recursively go on to it. I guess that's all. So you see, if we iterate with this example from 1, it doesn't have the left, so it won't call this one, but we append 1, and then it has the right one, so it will again go to 2, but 2 has 3, so it will first append 3 and then it will come back to 2. So let's test the code and hope it works. Yeah. So this was about the in-order traversal. See you again in next video. We'll be doing post-order traversal. Ta-da!